There's obviously a lot of hype at the moment, buzzwords, billion-dollar valuations being bandied around, but huge shifts are happening in technology and in AI especially. But across the world, we're seeing changes in geopolitics and tariffs, and these things are hitting the hardware that underlies AI, the picks and shovels that are powering this revolution. So I'm here to bring on two experts on stage. They are very familiar with making long-term bets on the markets in deep tech. So please let me introduce Peter Wennink, who's the former chief executive of ASML, and Sohn, who's the chairman of Samsung's Semiconductor Advisory Board and founding managing partner at Walden Catalyst Ventures.
Thank you, Christina.
Thank you. I'll let you both sit down. Let's just start with this insatiable demand for compute at the moment. It seems like demand is going up, and AI models are scaling up and up as well. So can we meet demand? Are we going to see a change to more inference-based structures? What do you think is going to happen in the next sort of 3 years?
Well, should I start?
Yeah.
Okay. Yeah. Good morning, everybody. I think that the size of data center will continue to expand as our data set increases. So the data is really what's driving AI, and the data is expanding. It doubles every 18 months. So you need even bigger compute, more memory, more network, and more power to support this. So if you look at in terms of overall the size that we should think about is we're talking about now million GPUs. And now million GPU doesn't sound big, right? But million GPU is a $40 billion worth of chips that are going in terms of the overall architecture and what's required. And the power to power this million GPU we're talking about gigawatts, 1.2 gigawatts. So this is a staggering number, and we used to think 100 megawatt was big. We're talking about 1.2 gigawatt, and we're not talking about just one center, but many others. So the amount of data center that are driving power alone will triple in 10 years. And that is the opportunity and challenges in many ways we've solved.
Yeah, and I'd like to add to that in the sense that you mentioned scaling. I think scaling will not stop. It's all about the increase of, it's all about density increase per square millimeter. And instead of just, historically, shrinking and increasing density in X and in Y direction, we'll go Z. So, and that's happening as we speak. So, from an ASML point of view, and when you look at the roadmap, there is the next decade no end to scaling. So this exponential increase in compute power and in storage will just continue. Over the last 50 years, we've built an industry that is supporting $600 billion worth of sales of semiconductors every year. Several analysts are making their calculations based on the data that they have, and they extrapolate that, and they think that this industry can double to 1.2, 1.1 trillion by 2035. That means that we need to increase the manufacturing capacity for semiconductors, which we built over the last 50 years, the next 10 years, to double it again. So yes, there will be significant investments needed, and it's going to happen.
We're starting to see some of these investments, or at least commitments to invest. Companies and countries have announced projects to build data centers all over the world. Stargate's the sort of most buzzy example, but it's not got completely off the ground yet. So how long does it take for these projects to actually happen? Do we have enough time? You mentioned sort of a 10-year time frame. Does it need to be sooner?
So I'm involved with some of those projects, and particularly as a member of board at ARM, we have announced the Stargate project. And the Stargate project is big. It's a $500 billion project. and it is funded through the SoftBank originally, and then there is a bunch of money that are coming in with the partners. It's an ecosystem of multiple players that are coming together, and I think what they're trying to do is really trying to realizing the AI is everywhere, and basically want to create data center capacity across the globe. And if you look at just the amount of data center that it requires, we're talking about 500. Now, we used in compute, we used to say flops, right? How many flops per second to measure compute performance. Now we're talking about watts, how much watts that are required. And we're talking about 500 gigawatts that are required to support these requirements going forward. So actually the first most important thing is power. Source of power, locational power, access to power, delivery of power, so, and closer to your data center applications. So the power is really critical. And then as Peter mentioned, what goes in there is about the geometry of chips and others, which is more about shrinking and reducing power need. So it's a demand to create less need, but then there's a supply challenges. These things will continue to be, I think, it will be an imbalance for a while. So as long as it's imbalance, there's a big opportunity.
Yeah, and I think the focus of the industry, that's not recent, I think it's at least the last 5, 6, 7 years, has been on energy efficient performance. Yeah? And I think what you just mentioned in terms of the energy need, that's a big problem. Yeah? You could think of it as a big problem, but the bigger the problem, the bigger the innovation. We will have innovations that will address that issue. I'm convinced. So it will happen. Yeah, and I think Young was very clear on.
Well, we have a lot of work to do. Yeah. To be honest, I was talking yesterday to some folks about the GPU architecture that are driving much of matrix-driven AI compute was kind of accidental in my view, rather than was designed to be optimized around, let's say, the way our brain functions. Our brain functions with almost 100 billion neurons. It runs at 20 watt power, much more efficient than the kind of compute that are happening with the GPUs today. So we need to figure out even better architecture that are more efficient, they can reduce the amount of power. The source of that power need, I think they have to be efficient. And the other big challenge is not just the compute. Compute typically takes about a 0.1 picojoule to compute the 1 bit. But actually where a lot of waste of energy is actually moving that information then into memory and then bring it back. Why do we have to do that? Because if you think about ChatGPT, you have to remember number of context, right? As you're speaking, remember what I said earlier, what you said earlier, what you said, put it all together in context. They have to remember this. All those things are going into memory. This long memory context is where the waste of energy is. And that ratio is 100 to X. So if you can figure out how to get the memory travel with the compute closer, we can reduce the whole architecture 100 times lower power. Imagine that.
So we'll solve that problem.
Is your sense, though, that we're moving, I guess, away from building models from scratch and instead looking at these kind of improvements in memory, and that requires a slightly different architecture? Peter?
Yeah, no, I think you can discuss types of architecture, whatever you want, but I think Young made it very clear. I think there is this challenge, this innovation challenge, this design challenge to make it much more efficient. While we happen to be where we are, because there was a structure available that helped us in the first instance, but it doesn't mean it's the end game. The end game is something different, and that will happen. And this is exactly, if you think about the number of startups that are thinking about solving parts of this problem, it's enormous. Yeah? Now, all of these startups are going to have to find the holy grail? Probably not, but the combination of them will. Yeah? We're just at the beginning. I mean, if you look at these major transitions, like the internet, it's 3 layers. It's hardcore technology layer that you need, and that's semiconductors. On top of that, you have the intelligence, layer. It's all the models that are out there, the JetGPTs, the DeepSeek models, and on top of that is the application layer. We're just scratching the surface. Yeah? We're also scratching the surface on, yes, we have a foundation on what I call the deep tech layer, but it's not finalized. It will develop. Yeah? And this is where the creativity and the startups that are focusing on solving some of these problems are so super important. And that money needs to flow there, because we will find solutions, and we will further elaborate on the intelligence layer and the application layer with just scratching the surface. It's like the internet. It took 15 years, 20 years before we all use it, and we can't do without. It's going to take time. It's not going to take 20 years for AI to reach those application levels. It's going to go faster. But it goes through this. And this is why there's a sort of a hype also now. Yeah, of course. Yeah, there's a hype, because we all feel, I'm old enough to realize that 25 years ago, 1999, 26 years ago, we had the internet bubble. I look around here, there's enough young people there that don't know what I'm talking about, but that was there also. It was a hype. But we all knew it was going to happen. It just took 10 years. Yeah? Now this is going to go faster. But this is where we are today.
I guess I wonder, what do you think's significant about this year? Because we've been talking about these issues for years now. I guess, is there something that's changed in the past 6 months that makes this more prescient, that makes it kind of more urgent to tackle, Young?
Yeah, well, there is a change in they call it the new mayor has arrived. And, so when I think about the late last year, I was thinking about things like technology, the tariff, right, and the trade agreement. But frankly, I think the new mayor in town, his name is something with a T, and making changes in our policies left and right. So it is very unpredictable to manage. And I think it makes every country, whether it's Korea, Netherlands, every country have to figure out, how do I survive in case the mayor doesn't support you, or in case the mayor change their mind? And I think this is a real reality that we are dealing with. We had 75 years of, in a way, dependency, in a way. But now there is independency that are coming, and that means there is a tremendous change in how we look at our defense policies, where we invest our money, self-reliance, self-resilience, and the national security have to be looked at in the context of how to protect yourself, rather than relying on Big Brother, because Big Brother may not be there when you need it. So this is the change, I think.
Oh, I completely concur. I mean, it's been, now, being a retired person, but still have my fingers into a lot of stuff and a lot of organizations, this sense of urgency that certainly organizations and companies and countries and geopolitical blocks in the world are certainly thinking about single-sided dependencies and as being unacceptable because of the unpredictability of Mr. T. Huh?
Let's just say Trump.
Really? Okay, that's a good guess.
That's good. So it's, and I think that has a profound impact on the way people think, and and it's good. I think I think publicly somewhere, it was also printed in a Dutch newspaper, said we might look back in 10 years from now, and we look back and say, hey, Mr. Trump could have been the best thing that ever happened to Europe. Why? Because I personally called the Netherlands more than 2 years ago fat, dumb, and happy. Yeah? And we were. Question mark. I think people have woken up, and also governments have woken up. The Times have now discussed with capital providers, pension funds, that are now interested in saying, okay, the Dutch pension funds, 1,500 billion euros assets under management. Only the Dutch pension fund. More than 60%, close to 2/3, is invested outside Europe, outside the Netherlands. The big question they now ask me is that, how much of that money should come back? Because we have pension premium collecting from our members and from our companies They need to benefit the social economic bloc where we exist. So that realization is kicked in. I've never heard that before. I'm 68 years of age and I'm 50 years in business, and I've never heard pension funds, but also government officials now certainly saying this. Yeah? Now, that's good, because that's the what. The big question is how. Yeah? I mean, that's going to be a challenge. How are we going to reorganize this and order it? But the things are changing.
And that will take, I mean, if it does happen, that will take a lot of capital, and it will take several years to really get off the ground. In the meantime, the more established players aren't going to stop. So is it credible that Europe can emerge as even a competitor here?
Well, I think two of us are a good example of being involved with this topic of dominance. Actually, the global dominating companies that came out of Europe. So I was involved with ARM. I'm still on the board of ARM. And Peter is involved with ASML. And if you look at what it took to build these great companies from Europe, from university town, in the case of ARM would be from Cambridge, from the Dome, and it was about ecosystem. It wasn't even the best architecture at the time, because eventually there is a higher bit, 64-bit architecture from MIPS, but actually this small company out of England, they decided to be a peacemaker. They decided to give their IP to pretty much everybody around the world, so that everybody doesn't have to recreate this processing architecture that are needed for lower power. And Intel, at the time, was poo-pooed on this lower power toy idea, but ARM worked on this idea from underneath, like innovators challenger, and actually then convinced some of big customers like Nokia and others to use it in the 1990s. And today, every mobile phone they use today in your phone is based on ARM architecture. ARM is also moving into data center. If you look at Amazon's all new chips are based on ARM architecture. So this is a change that are happening that came out of Cambridge. And this is a European project, and this is a company that built ecosystem of software companies, network, drivers, OEM customers, and being a very diplomatically spreading this IP, make it easy to use, and supporting customers with the transition to design wins. And in the process, now this is the most dominating architecture today, and this is what the Intel's problem is. Same like ARM, I think ASML has a fantastic story. So Peter.
Yeah, I was going to say ARM's not European anymore, really. But
wait, which country is that?
Well, I mean, that is also an issue of capital. But let's talk about. I think it's absolutely true. I mean, if we don't believe that Europe can get its act off the ground, then why don't you guys go out of the tent, go to the beach, enjoy as long as it lasts? Yeah, that's not what we should be doing. I mean, there is so much creativity there. ASML was built exactly like that, bottom up. When ASML started, there were 13 companies that did the same thing. We're effectively the only one left. Yeah? And why is it? Because what ASML's product is very complex. And it's the same with startups. It's not about the idea. It's not about the technology. It's important. But it's about how do you get it off the ground. And when something's very complex, then you don't know what you don't know. But somebody else might that can help you. So it's really creating this ecosystem of collaboration, of technology partners, of customers, super important. Customers will, in fact, design your product because you have to listen to them. And that's what I see when I talk to startups and you ask these questions. It's about industrialization. And industrialization is not so much about the manufacturing, which it is, but it's also about where is the value for the end customer, and do I understand that? What does it mean for my product? What does it mean for my technology? And how can we interact? And what does it mean for my suppliers, for my knowledge partners then? So can I collect that? ASML is a system architect, a system integrator. Yeah? And we're making the most complex machine on the planet. Yeah? So that can be replicated. Why? Because I strongly believe that there is this called the European mentality, because we come from behind, which was the same for ASML, that there's an intrinsic desire to collaborate. Yeah? And that's what you need to do. But the main condition for collaboration is that you have a fair sharing of the risks and the rewards of what you're trying to do together. Yeah? And that is a European trait. I mean, ASML's technology is European. German, Dutch, Belgian, Swedish, French, all kinds of parts. But it's European. It's the result of collaboration, of system integration, whereby we realize that reaping the benefits can not only come to us, it needs to go into the ecosystem, and that is a trait that's pretty European. Now, the reason why we worked together on the acquisition of Cymer, which actually was the core of the light source to make the EUV system, which is well, we did that, and we needed to integrate that because the collaboration needed to strengthen more than just being at arm's length. Yeah, it was an American company, public company, Dutch public company. Who gets the value? That was a big fight. If you put it all together, it's over. Yeah, so you know it's simple.
I find it's interesting and inspiring to hear you talk about collaboration and this potential, but for startups to be a real success here, they need global customers, they need global cooperation.
Yeah.
As we've mentioned, it's pretty unpredictable at the moment. We can't necessarily trust traditional partners to not flip-flop all of the time.
That's true.
And there's political unrest across the world as well. So how should companies be approaching this? How do they know which strategy to pick? And is it a case of being really flexible, or is it a case of picking one route and sticking to it no matter what else is happening?
Well, I can only talk from ASML point of view because we were local. We had to go to the US to find this technological solutions, but 98% is European. So obviously there's something here in Europe in terms of competence and creativity and partnerships that you can use to build a company. And of course then you can connect to customers. I mean, the world is not closed. Yeah? Let's be honest, you can still do business in Asia, in North America, in South America, in Africa. You can do everywhere. Yeah? So the world is not closed. But for me it's very important to say, try to find partnerships first in the locality. It doesn't not mean only the Netherlands, but in Europe, European technology institutes, customers. Once it's easier, yeah. But also it shields you a bit from this roughness, yeah, in terms of international trade barriers or export controls.
Yeah.
Sorry.
Well, I think in the perspective of technology-driven companies, particularly deep tech, trust is there is no border. Maybe there is a geopolitical with China, and so there is just some separation because of IP leak. But at the end of the day, you have to build the best company with the best technology, with the best customers you can find. Here, if you have too many constraints, you'll never get there. Yeah. So Arm decided to be a targeting global market space and went from a most important customers around the world. And this is the mentality you got to have. Because in the area of especially deep tech, it's a binary outcome. Like delivery companies, you can have a delivery company in Berlin, in Paris, and Amsterdam, doesn't matter as much. But when you are in a deep tech that are providing, let's say, lithography tool, every customer want to use the best tool.
Yeah.
Every customer want to use the best chip. Every customer want to use the best tester. So in that circumstance, you have to build the best thing, and you have to be the best in a scale you're in. Now, I'll just give you one observation, since one of my job, since I retired from Samsung, is I'm a venture capitalist. So I invest in companies, and we invested about 600 companies in tech space. We took 139 IPOs, so we have some relevant experience in building successful IPO companies. And what we learned from there is that, one, you need to have good partners. There's no competition. When you're going into a project, I'm always looking, who can I work together to build even bigger pie together? So that mentality. Two, the company needs to have a clear mode of differentiation, because it's just a Me Too kind of companies are not going to do it. So you have to think through what are the uniqueness that they are doing that can be able to build your sustainable business and business reward that comes with it. And then most importantly, management team. Management team that can be scaling and globalizing. As you know, Europe has as many startups as actually America. But scale up, the percentage scale up in Europe is only 8%, whereas more than half of that is in Silicon Valley. Why? So we have to think through the speed, the venture capital community that requires, some of the friction that we talked about from government policy perspective. These things all have to be addressed to increase the speed and scale. That's the only name of the game in tech. How fast can you go? How good you are? What's the scale? That's the name of the game.
I might just pivot slightly because, Peter, you're on the supervisory board for Heineken, and some people in the crowd might be a little bit thirsty right now, maybe not for beer, a bit early, but I wonder what we're seeing in sort of global consumption trends with alcohol, and perhaps how that might reflect what's going on in the wider markets at the moment as well.
Yeah, no, I think people ask the question, why are you now the chairman of, Heineken? Because I think, chips and beer are a good combination for me.
Wait, potato chips?
Yeah, potato chips, yeah. But but that's a very complex company from a manager. Why? Because they're global. That's exactly what Young said, their customers all over the place. Now, the problem is currently, I think for every consumer-related company, it's fast-moving consumer goods, is based on the confidence, the consumer confidence. And that is actually, that's got quite a big dent in the last 6 months. What's happening across the globe? And that is the word that's most used. I just read an article this morning. The word has been most used in all the analyst calls and the company quarterly earnings, calls is uncertainty. Even more than during the financial crisis.
Wow.
Yeah? So that means that has also an impact on the consumers. But these things all refer to the mean. We'll figure it out. Yeah? So this will change again. So that will come back. It will also be the driver for all these new applications that are being fueled by AI over time. So I'm an optimist. That worries a lot, but that is going to be fine. But from every consumer company today, we can see it, has to deal with that uncertainty. Yeah, it's what it is. But it will change.
Young, your thoughts?
Well, Samsung is a consumer electronic facing company. I think overall demand post-pandemic has been flat and the global perspective. So that indicates that there is no big stimulator at this point. The only industry that are really growing today is really AI-driven, and it makes sense. It's a big wave of opportunities, and I think that's where the action is today. We'll see what next.
Great. Thank you so much to both of you for speaking to me. Peter Wennink and Young Sohn, thanks so much for listening.